Hello to everyone. In this video, let us discuss ionic equilibrium in that acids and bases definitions and Arrhenius theory, Bronstead Lowry theory. First, let us see what are acids and bases. So we know that general definitions or general characteristics of acid are which one. Acids are which one here sour to taste. So now the example is here lemon water. That is an example of which one acid because that is having sour taste. And like that bases are having which one here bitter to taste. Bases are bitter to taste and they convert red litmus to blue litmus. Acids convert blue litmus to red litmus. Like that here we can define which one here acids and bases, and both acid and base aqueous solutions are electrical conductors. And now to define acid and base exactly, some theories are there. In that the first theory is Arrhenius theory. According to Arrhenius theory, the substance which produces H plus ions or hydronium ion in aqueous solutions, that substance is said to be an acid. Examples are which one here? HF, HCl, HBr, HI, HNO3, HNO2, H2SO4, like that. So many we can write. So the substance which produces hydronium ion in aqueous solutions, that is said to be an acid according to Arrhenius. And what is base means here? The substance which produces hydroxyl ion in aqueous solutions. Now that substance is said to be which one? Base. Example here NaOH, KOH, CSOH, etc. like that. And here, according to Arrhenius theory, what is neutralization means? Reaction of acid with base to give salt and water. That reaction is said to be which one? Neutralization according to Arrhenius theory. But so many defects are there in this theory. First defect is this theory applicable to aqueous solutions only, and this theory could not explain acidic nature of HCl in vapor phase. It could not explain acidic nature of HCl in vapor phase. And similarly, this could not explain acidic nature of SO3, CO2, SO2, etc. And also BCl3, BBr3. These are also having acidic nature. Those acidic nature could not be explained by Arrhenius theory. And also this could not explain basic nature of NH3 and another one BaO and CaO, etc. These are having basic nature, but their basic nature could not be explained by Arrhenius theory. So these are the drawbacks, defects, limitations of which one? Arrhenius theory. Now the second theory was proposed by Lowry and Bronstead. At the same time, both the scientists proposed the same concept. So this is known as Lowry-Bronstead theory. According to Lowry-Bronstead theory, let us see what are acid and bases here. So first let us go for acid. And this theory is also known as protonic theory. Why it is named like that, let us know here. So according to Lowry-Bronstead theory, the substance which donates proton is known as an acid. Proton donor is known as an acid. So what are the examples? Let us see here. HF, HCl, HBr, HI, HNO2, HNO3, H2SO4. If you remove one H plus from this, it is a dibasic acid. So we get HSO4 minus. And as it is a dibasic acid, still one more H plus we can remove from this bisulfate ion. So this also can act as an acid. But after removal of H plus, we get SO4 minus 2. But that cannot act as an acid because no H plus ion present in SO4 minus 2. It can't donate further proton. Okay, then come to another one here. HCN, it can donate proton. Okay, then H3PO4. This is orthophosphoric acid. It is a tribasic acid. Tribasic means what? What is the meaning of tribasic acid? It can donate 3 H plus ions. So that means this can act as an acid. By donating one H plus we get H2PO4 minus. This also can act as acid. HPO4 minus 2. This also can donate proton. So this also can act as an acid. Next PO4 minus 3. But this unable to donate proton because no H plus ions are there. So this does not act as an acid. Now come to the another one, H3PO3. It is a dibasic acid, means it donate only to H plus. Of course, 3 H plus ions are there, but the third, that hydrogen is directly bonded to phosphorus. Which one? Third hydrogen. So it could not donate 3H plus, only that donate 2H plus ions which are bonded to oxygen atoms. So now it is a dibasic. So this can act as an acid. After removal of one H plus, H2PO3 minus, and after removal of another H plus, HPO3 minus 2. But here there is hydrogen, but it could not donate that H plus because the third hydrogen directly bonded to phosphorus, so it does not come out as H plus ion. So this does not act as an acid. Okay, then come to another one, H3PO2. It is a monobasic acid, donate only one proton. So this can act as an acid. By donating one proton, it gives H2PO2 minus. But this does not donate to further proton because these two hydrogens are directly bonded to phosphorus. So it could not act as an acid. And if you come to another example, H3O plus, by donating one H plus, it gives H2O, then OH minus, then O minus 2. But O minus 2 does not act as an acid because no H plus ions present in that. Then NH4 plus, NH3, NH2 minus, NH minus 2, N minus 3. But N minus 3 does not act as an acid because no H plus ions are present in that. So like that, we can write so many examples for which one, that Bronstead Lowry acids. All these can act as which one here, Bronstead Lowry acids by donating protons. So proton donor is known as an acid. So we have to remember some are just they can't act as which one here, acids, because of absence of which one, H plus ions, and some which we have observing here again repeat in case of bases also. We have to note down at that time. Okay, now let us see what are the bases examples and what is the definition of a base as per Lowry Bronsted theory. So as per Bronstead Lowry theory, what is base means here? The substance which accept a proton from other substances is known as which one, base. That means proton acceptor is called base. I think now we come to know why that theory was named as protonic theory, because that both acid and base defined with respect to proton. So that's why only this theory is called protonic theory. Now, which can accept a proton from other substances, that is known as a base. So now let us see examples for bases here. F minus, Cl minus, Br minus, I minus, and next NO2 minus, NO3 minus, and here from next we have to go for some examples here. SO4 minus 2. By accepting proton, it form HSO4 minus. So it is acting as a base. But we come to know that this doesn't act as an acid because SO4 minus 2, as it containing no H plus ions, it does not act as an acid. But by accepting proton, this acts as a base. That means SO4 minus 2 acts as a base only. But if you come to HSO4 minus, by donating H plus, it can convert into SO4 minus 2. That means it can act as an acid. And at the same time, by accepting proton, it can form H2SO4. That means HSO4 minus present in which one? Both acids and bases category. So we have to note down the type of substances. And another one here. Next, PO4 minus 3. By accepting proton, we can get HPO4 minus 2. And then, next, this can also accept proton and form H2PO4 minus H3PO4. But this does not accept a proton. So that means this does not act as which one? This does not act as, okay, this one also does not act as which one? A base, because this can't accept proton. Now here also this can't accept as the can't accept which one? Proton. So we have to remember some things here. Among these three, SO4 minus 2 acts as Bronstead base only, but doesn't act as an acid. And H2SO4 acts as Bronstead acid only, but couldn't act as Bronstead base. But HSO4 minus, that can act as both Bronstead acid and base. And similarly, come to this example also. PO4 minus 3 acts as Bronstead base only, and H3PO4 acts as Bronstead acid only. But these two can act as both Bronstead acid and base. Such type of substances are called amphoteric substances. The substances which acts as both Bronstead acid and base, or both acid and base, are known as amphoteric substances. Okay, now come to another example here. What is that? HPO3 minus 2. By accepting one proton, this give H2PO3 minus 1. By accepting one proton, we get H3PO3. But this H3PO3 can't act as a base because it couldn't accept proton. And HPO3 minus 2. This acts as a base only, but couldn't act as an acid. But this one, H2PO3 minus 1, can act as both acid and base. So the substances which acts as both acid and base known as amphoteric substances. And similarly here, O minus 2, that accept proton give OH minus, this also accept proton give H2O, this also accept proton give H3O plus. But H3O plus can't act as a base because it couldn't accept proton. So in this also, O minus 2 act as a base only, H3O plus act as acid only, but these two acts as both acid and base. That is called which one? Amphoteric substance. Okay. Like that, we can write NH4 plus example also. That means what we can write here, N minus 3, NH minus 2, NH2 minus 1, NH3, NH4 plus. But NH4 plus does not act as which one? That base, because it could not accept a proton. So now in this category also N minus 3 act as which one? Bronstead base only, and NH4 plus act as Bronstead acid only. But the remaining three here, what are those? NH3, NH minus 2, NH2 minus 1. These three can act as both Bronstead acid and base. Those are called which one? Amphoteric substances. Okay. These are the examples for which one? Bronstead acid and base. Now, what is neutralization? Let us see in case of Bronstead Lowry theory or Lowry Bronstead theory. So, some examples let us consider here. First example here, NH3 when treated with H2O, we get NH4 plus OH minus. So this process is called neutralization. What is the definition of neutralization? Transfer of a proton from an acid to a base is known as neutralization according to Bronstead theory. Transfer of a proton from acid to a base. So now in this equation, NH3 converted into NH4 plus. That means it is accepted proton. As it is accepted proton, let us consider that as a base. And see here, in this forward reaction, H2O changed into OH minus. That means that has been which donated which one? Proton. So this is considered as acid. And in backward reaction, NH4 plus converted to NH3 means it is donated proton. So in backward reaction, this is acid, this is base. So now here, this is acid 1, acid 2, base 1, base 2. So now this reaction is called neutralization. Transfer of a proton from an acid to base is known as neutralization. In one neutralization reaction, if you observe here, two acids and two bases are formed. That means one neutralization reaction contains two acid base pairs. Now let us write what are the acids and related bases. H2O, related base is OH minus, and then another acid NH4 plus, related base is NH3. Now, this acid base pair has one name. What is that? Conjugate acid base pair. What is a conjugate acid base pair? The acid base pair differ by one proton. See here, H2O OH minus differ by one proton. So the acid base pair differ by one proton is known as a conjugate acid base pair. And another important thing here, if an acid is the stronger one, its conjugate base is a weaker one. If an acid is a stronger one, its conjugate base is a weaker one. Remember like this, Pandita Putra Paramashunta. Remember like that. If acid is the stronger one, its conjugate base is a weaker one. Okay. If acid is a weaker one, its conjugate base is a stronger one. So now how we can get the questions regarding conjugate acid base pair? Let us see here. So the first question is here. They give what are the conjugate acid or conjugate base of something. So now the first question, what is the conjugate acid of, what is the conjugate acid of NH3? The question they give like this here. Of course, different formulas are there to know what is conjugate acid or conjugate base here. No need to go for the different formula here. One simple question I will give here. So what is that simple question means? What is the conjugate acid of this one they are asking means? It should act as acid or base. We have to think first. A simple example, on the back side of the door some X person is there. Now we are not observing who is that X person, but that one person asked that X person, what is your wife name? What is your wife name? That question asked means that X person should be which one belongs to male gender. Like that only here. What is the conjugate acid of NH3 we are asking means it should act as a base. If it acts as a base, what it has to do? It should accept a proton. So by accepting proton, now we can get which one? NH4 plus. So now conjugate acid of NH3 means nothing but which one? NH4 plus. If the question they have given like this, what is the conjugate base of? What is the conjugate base of NH3? Conjugate base of NH3 they are asking means this should act as now which one? Acid. According to this theory, an acid means that should donate which one? Proton. So by donating proton, it will produces which one? NH2 minus. So like that we can go for different examples. Now, what is the conjugate acid of H2O? Conjugate acid of H2O means it should act as a base. It should act as a base means it should gain one proton, should accept one proton. So by accepting one proton, now this will give H3O plus. The same question, what is the conjugate base of H2O? What is the conjugate base of H2O means it should act as acid. It should act as acid means it has to donate one proton. By donating one proton, we get which one? OH minus ion. And another important one here, what is the conjugate base of, I give one question here, AlH2O taken 6 plus 3. What is the conjugate base of AlH2O taken 6 plus 3? Conjugate base is the question means this should act as an acid. Acid means it has to donate which one? Proton. So now take one water molecule out and remaining 5 I am writing here. From that H2O, remove one H plus. If one H plus ion has been removed means here OH minus is there. And this minus now combine with plus 3. Now net charge is plus 2. This we have to identify. Because sometimes plus 3 only we can ignore that charge, change in charge. But we have to change the charge from plus 3 to plus 2. So this is the conjugate base of which one? AlH2O taken 6 plus 3. And another question they give, which of the following is strong conjugate base? Strong conjugate base. So options F minus, Cl minus, Br minus, and fourth option I minus. Which is a strong conjugate base? Strong conjugate base means that should be generated from weak acid. So among HF and HCl, HBr, HI, as HF is a weak acid, therefore F minus is the strongest base. So like that we have to answer for which one? Strong conjugate acid, weak conjugate acid, etc. Okay. In our next video, we can go for Lewis acid base theory. Bye.